So, a quiz on all the Physics 12 forces stuff. This is a really good indication of the level of difficulty of the written section and the level of expertise, the stuff you'll be expected to handle on the written section. I underlined the phrase from rest. It's just a habit, but that means VI is 0. I said, well, they want me to find the time. So I started out by going, well, T equals question mark. VI equals 0. D equals 5.8. I'll pause my recording while my young late student totally lost my train of thought, but we're going to keep going here. I said, I think I can find, if I can find the acceleration, I can use this. D equals AT squared over 2. I didn't bother writing the VIT because VI is 0 from rest. I think I can find time by going 2 times D over A square root. So although this question said find time, I think I'm going to spend most of my time finding the acceleration. How? Oh, this is a job for a good free body diagram. So I'm going to label my forces. Gravity down. I'm going to break gravity up into its components. There's going to be a normal force. Which way is this sliding? Down the ramp. Is there friction? Yeah. Then friction is going to be up the ramp. Find what you're looking for yet there, fella? Yeah, no kidding. Okay. If I had, on your test, Nikki, I will be asking you on the written section somewhere, 4 marks, to do a free body diagram. The blue lines would be the free body diagram, not the red components. I don't put components on an actual free body diagram. And that's why you always hear me say, well, technically I'm just labeling my forces. I'm not doing a proper free body diagram. Technically a free body diagram represents the mass with a dot and all that stuff. Anyways, who's winning? It's a good question. Is it speeding down or slowing up? I'm going to assume, is it speeding down or slowing up? Wow, that was pretty good. See what happens when someone shows up late? It wrecks my whole, okay. Is it speeding up or slowing down? I'm going to assume gravity parallel is winning. If I'm wrong, I'll get a negative answer with my friction, with my acceleration. I'll fix it. Anyways, I'm going to go like this. I think it's going to be mg parallel minus friction equals ma. It's going to be mg sine theta minus mu times the normal force equals ma. I don't know the normal force. Oh, but look. I know another force the same size as the normal force, mg perpendicular. So it's going to be mg sine theta minus mu mg perpendicular equals ma. Hey, kind of cool. The m cancels. You don't have to, but it does. G perpendicular, of course it is. G sine theta minus mu g cos theta equals the acceleration. So the acceleration is going to be 9.8 sine, what was theta? 58 degrees, that's a pretty steep hill. Minus, what's mu? I don't know, what's mu with you? 0.34 times 9.8 cos 58. Let's see if I guessed right. Let's see if this thing is accelerating. Because it could be slowing down. 9.8 sine 58 minus 0.34 times 9.8 cos 58. Made sure I'm in degrees. Is that right? I typed that. Is that right? Am I in degrees? You know what? I'm not in degrees. I know why. There we go. Because I had to reset my calculator yesterday because I bought a new keyboard, and so I had to Anyways, let's try that again. Because I am, but I forgot I had to reinstall everything yesterday. There you go. That was in my face. Now, by the way, my built-in error check, I was going, wait a minute, in free fall it would be 9.8. To say it's 9.3, so close to free fall, I don't think so. 6.54, okay, that seems better to me. I'm going to go 6.545. Because they didn't ask me to find the acceleration, they wanted me to find the time. So the time is going to be the square root of 2 times d over a. It's going to be the square root of 2. They gave me a distance, did they not? 5.8. All over 6.545. 2 times 5.8 divided by answer button, square root. Do you get 1.3? 1.33 seconds? So if you got that, that gets you 4 out of 4. Otherwise, how would I give out part marks? First of all, on the test, you're going to find on my tests, written questions are almost always worth 7. So I would have more part marks to give out. Here, with only 4 marks, I would probably do something like this. Give you 1 mark if I saw that line somewhere, because you clued in, you have to get the t by itself. That's important. I would give you half mark if I saw that. Half, you know what, let's not be so fussy, Mr. Dewick. Let's go like this. I'll give you 1 whole mark if I saw that. I would probably give you 1 whole mark if I saw. I'll even give you the line before canceling out the masses. But if I saw that you'd replace sine and cos in there, and then 1 mark for the acceleration. If you got the acceleration wrong, you can still get, you know what, I don't have any marks for the answer. That's no good. Okay, I got to revamp this marking scheme. Good gosh. Because I need 1 mark for the answer, so it's going to be a half mark for that. Probably a half mark for that. A half mark for that. 1, 2, 3, and a half mark for the acceleration. There, that gives me 4 marks. I don't know. Number 2. Find the tension in the rope. Mass 1 is 3.9 kilograms. It's accelerating upwards. Okay. M1G tension, and tension's winning. My equation is going to be winner minus loser equals M1A. I didn't do a looking at both because I don't know one of the masses, so why do an M both, A both? I've got a mystery mass. But I can get the tension. Tension is going to be M1A plus M1G. Tension is going to be M1 3.9, A 2.6 plus 3.9 times 9.8. Can I do that one in my head? It's going to be times 12.4, maybe. 4 times 12.4 would be a 48 plus a 1.6, so it would be a 49.6. 49 point... Nah. I had it for a second there, and I think I forgot to carry something. 48! Yeah, I forgot to carry something. I'll go 48.4, but I'll keep the 48.36. Newtons. If you wrote that, that gets you 2 marks. Otherwise, I would go probably a half mark for that equation, a half mark for getting the tension by itself, half mark for the numbers, and a half mark for the answer. Find M2. Okay. For M2, I have M2G tension. You know what? The equation for mass 2 is gravity is winning, tension is losing, and that equals M2A. How many M2s do I have? 2. How many would I prefer? 1. Why don't I get them to the same side? I'll plus the tension there. I'll minus the M2A there. And that's going to give me M2G minus M2A. That equals tension. How many M2s do I have? 2. How many would I prefer? 1. You know, it'd be really cool if it was a grade 9 mathematical operation that I could pull out of my back pocket. There is. It's actually, I can factor out a GCF, a greatest common factor, and I'll get tension equals M2G minus A. Tension equals M2, you know what? G minus A would end up on the bottom of the tension. Mass 2 is going to be 48.36 divided by 9.8 minus 2.6 divided by 9.8 minus 2.6. Y'all get 6.72 kilos? Okay, that's what I got. Thank you for that anguished cry of despair. That would get you 2 marks. Otherwise, I would probably go something like this. I would give you a half mark if I saw that. I would give you a half mark if I saw that you had cleverly factored. I would give you a half mark for getting the M2 by itself, and then a half mark for the answer. Number 3, I'm going to give you one possible explanation, and then if you want to, after we finish marking the quiz, you can show me your explanation, and I'll tell you whether I give you 2 out of 2 or not. I think for the first one, if everything is horizontal, the scale is just going to read the mass. Imagine if you stood on a scale in a moving train that was moving very slowly. Your mass scale reading, your normal force doesn't change. Rolls down the skateboard on a ramp. Skateboard, scale. I'm not going to try and draw the person, but I could put the forces on there. We would have gravity down. Oh, there's angle theta. We would break this up into components. mg perpendicular and mg parallel and normal force. For you to get full marks, if you did the free body diagram, something like that, I would probably give you 1 mark. And then I would say this. Scale measures normal force. I think you should mention that. Sorry, I can't give you a full mark. I'll give you a half mark. Actually, I'll give you a full mark for saying that, and I'll tell you why in just a second, because you could answer this without a free body diagram just by knowing this. On a ramp, normal force equals mg perpendicular, yes? Which is less than mg. In other words, that. Now, other possible explanations. One of the ways we did this was we looked at the extremes. You could say, well, if theta was 90 degrees, what would the scale read? 0. So you could say, as theta increases, scale reading goes down. I'd take that'd be a perfectly valid explanation. You could, I had one student say, Mr. Duke, what if I just made up numbers? What if I let theta be 30 degrees? I let the mass be 70 kilograms, and I just crunch the numbers. I would totally take that. So one of my students actually calculated the new normal force, and it was smaller than mg, and they wrote that all up. I'm totally fine with that. Robbie, you know me well enough to know I have a fondness for a nice algebraic answer with as little English as possible. Okay. In fact, you know what? With as little English as possible. There. Which is, I could get rid of that and just say an mg parallel perpendicular. It's going to be less than. Why is it less than? Because cosine is a decimal. When you multiply mg by decimal, you're going to get a smaller answer. You could really go into depth if you wanted to. Number 4. Find the acceleration. Okay. M1g, tension. M2g, M2G perpendicular, M2G parallel. Oh. Normal force, tension. Who's winning? Well, the tug of war is between those two. So really quickly, I'm going to go M1, 12 times 9.8. Oh, you know what? Wait a minute. Is this mass heavier than this mass? And this is the one that's dangling completely in free fall? This one's going to be winning. It's going to be winning. Because this one here, I'm going to be dealing with a component. It's already going to be smaller because it's a component. And it's a smaller mass. You can crunch the numbers, but I can tell you, you know what? A heavier mass is going to be a winner in an Atwood machine. Unless there was friction. But there is no friction. So my equation is going to look like this. M1G minus tension plus tension minus M2G parallel equals M1 plus M2 times A. Everybody but James can do that. James should be feeling a little tension. Oh, no, wait a minute. I already said the app, so I let you off the hook, didn't I? Jeez. You should still be feeling tension. Why did I write M2 as a little subscript there? I don't know. Let's try that again. M1 plus M2. So the acceleration is going to be M1G minus M2G sine theta divided by M1 plus M2. Let's plug and chug. It's going to be M1 was, 12, 8.8, and 38. 12 times 9.8 minus 8.8 times 9.8 sine 38, all divided by 12 plus 8.8. Is that right so far, I hope? 12 times 9.8 minus 8.8 times 9.8 times sine 38 divided by 12 plus 8.8. That looks right. Do you get 3.1? Yeah? If you got that, 2 out of 2. Otherwise, I would give you a half mark for this equation, a half mark for this equation, a half mark for the numbers, and a half mark for the answer. Find the tension in the rope. I'm going to use this mass to find the tension because it's way less convoluted. Even though I think in that mass, tension's a loser, it's still going to be way easier. So I'm going to say M1G minus tension equals M1A. Plus that there, minus that there. I'm going to get tension equals M1G minus M1A. Tension is going to be M1 was 12, G minus 12 times 3.1. 12 times 9.8 minus 12 times answer button. 80.4? No, yes, yep. Newtons. 2 marks. Otherwise, half mark, half mark, half mark, half mark. What would the minimum coefficient of friction need to be between M2 and the rope in order to hold the entire system stationary? Stationary is the key word because that means that A equals 0, which gives me a much, much nicer equation. Okay, so there's friction. Which way would friction have to be pointing if M2 wasn't moving? Down the ramp. I could probably, if I was clever, tackle this by looking at one mass or the other, but I'm going to do the full-blown equations. So I'm going to go, okay, who's winning? M1G minus tension plus tension minus M2G parallel minus friction equals 0. Tension cancels. And because I want to get mu by itself, I'm going to plus friction over to this side. I'm going to get M1G minus M2G parallel equals mu times the normal force. I don't know the normal force. Well, first of all, I'm not going to say that yet. What am I trying to find? Mu. Let's get mu by itself. How would I get the mu by itself? I think I would divide by the normal force. Yes? Whoop. So mu is going to be M1G minus M2G parallel divided by the normal force. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. Mu is going to be M1G minus M2G parallel divided by M2G perpendicular. Mu is going to be M1G minus M2G sine theta all over M2G of cos it is. Running out of room here, so I guess I'm going to start plugging in numbers. It's going to be bracket 12 times 9.8 minus, what was, 8.8? Times 9.8 times the sine of 38 divided by 8.8 times 9.8 times the cos of 38. Typos. Is that right? No, that's way too big. Is that right? What's he got? Oh, is it 0.95? No? Yes? No, I might have done it wrong too. Let me double check. What, you got this? 0.95? How many got 0.95? Okay, I think we're going to go with the consensus, and I think that's it. 0.949. What are the units from mu? Nothing. Okay, that's a tough question. I would give you probably half mark for that. Really, I need to give more marks for this. I would probably give you half mark for getting the mu by itself, half mark for doing the trig, and a half mark for the answer. Then I would turn the page. Number 5 is asking me to find mu. Okay. mg perpendicular and mg parallel. Normal force, and I think friction is going up the hill. Who's winning? Well, I think for skiers, I think the parallel component of gravity down the hill is winning. Who's losing? Friction. That equals ma. mg parallel minus mu times the normal force equals ma. I know I want to get mu by itself, so I'm going to plus this to that side and minus that to that side. That's going to give me mg parallel minus ma equals mu times the normal force. Divide by the normal force to get mu by itself. Okay, I'm getting somewhere here. Mu is going to be mg parallel minus ma, all divided by, I don't know the normal force. Oh, but look. mg perpendicular. I think the m's actually cancel. I think I might have been able to do that earlier, but there is an m in everything. Don't have to, but it does. So I'm going to get this. Mu equals g parallel. That's going to be g sine theta minus a all over g cos theta. Do I know the angle theta? They gave me that, didn't they? Yeah, 16 degrees. Do I know g? 9.8. Do I know the acceleration? Not yet. So right now this is unsolvable. Maybe they told me other stuff. Let's see. VI is 0. VF is 20. T is 10. Hey, I can find the acceleration. I can go A equals VF minus VI over T. It's going to be 20 minus 0 over 10. In fact, I can feel like Mr. Dewick. I can do this in my head. Wow, that's kind of cool. That's what Mr. Dewick feels like when he does math in his head. Kind of nerdy, kind of proud. Little nerdy adrenaline rush. Yeah. 2 meters per second squared. Plug that in over here. 9.8 sine theta was 16 degrees minus 2 all over 9.8 cos 16 degrees. 9.8 sine 16 degrees minus 2 all over 9.8 cos 16 degrees. Do you get 0.074? Which for snow seems reasonable. If I'd gotten a 0.9 here, either Dewick made up bad numbers, which happens sometimes, or I'd go check my math, because the coefficient of friction on snow close to 1, that would not be a good ski run. So 0.0744, that's the 3 sig figs. Units, there are none. I would give you 1 mark if you found the acceleration. I would give you 1 mark for the answer. I would probably give you 1 mark for that equation, and I would give you 1 mark if you had the mu equation by itself. There's your 4. Last one. I like this question. Well, the first thing it says is draw a free body diagram. So I'm going to be fussy. Since they gave me space to draw a free body diagram, I'm only going to let you mark what you put in this space. If you also labeled your diagram, that doesn't count. Draw it here. So, a proper free body diagram, what are the forces acting on this object? Get the obvious one. Gravity. What else? Normal force, a little weird. I'll come back to that. What else? Definitely the applied force. You could have labeled that with a 140 or with an applied. Normal force, bigger, smaller, or the same size as mg. So I'm going to be fussy here. For you to get full marks, your normal force has to be clearly smaller than mg. What did you say? I heard another force? How big? Is this moving? So is it accelerating? Is it accelerating? So all the forces must be, I'm looking for a word that begins with letter B. So I'm imagining, can you imagine the components of the applied? I think friction is going to be exactly the same length as Fx. Has to be. I'm going to be fussy. That friction should be approximately the same length as that component. Hey, how many lines did I draw here? How many marks is this worth? How about a half mark per line? So, I mean, the nice thing is it's pretty tough not to get at least 1 mark. But then half mark, half mark. Having said that, I'm now going to go label my picture and break it into components. Now, if you chose to break this into components, I'm okay as long as you did your components with dotted lines. If you chose to break up this diagram, that's fine. I'll give you the full marks for the free body diagram. But I'm going to quickly redraw this here. I have gravity down, smaller normal force up. I have the applied, so it's going to be Fx, Fy, and friction. Nevada, what did B want me to find? my first thought in my head, I said, oh, Duick. And then I freaked because there's no mu. So I said, okay, there's got to be some other way to find friction. And then my brain said, oh, I don't know friction. Oh, but look. I know another force the same size as friction. And that's the key to doing this question. The fact that it's not moving. If they hadn't told me that, this question is not solvable. But the fact that it's not moving, I think I can say friction and the horizontal component are tied. Fx, sine, cosine, or tangent. It ends up being cosine. You can do the trig. You'll get adjacent, hypotenuse, opposite. So I said, well, friction is going to be the applied force times the cosine of theta. The applied force was 140 newtons. And the cosine of theta is 28 degrees. Times 28 times cos 28, Mr. Duick. Do you get 124 newtons? I'm going to go to 3 sig figs. So if you got that, that would get you 2 marks. I would give you 1 mark for that, half mark for that, half mark for the answer. If you said friction is mg times and you made something up, I'm going to give you a 0. Can't do that. Normal force, I don't know the normal force. Oh, but look. Ooh, lawnmower. Mr. Duick says be careful. Oh, no, Mr. Duick says everything up equals everything down. So, as an equation, it's going to be normal force plus Fy equals mg. I guess normal force is going to be mg minus Fy. Oh, yeah, normal force will be smaller. Fy. FYI, what's Fy? Sine, cosine, or tangent? Sine? Oh. So it's going to be mg minus 140 sine 28. What's m? Please tell me. 45? 45 times 9.8 minus 140 sine 28. 45 times 9.8 minus 140 sine 28. And I get 375, is that right? Now, one of the nice things about my calculator is I've got a multi-line display. Oh, I would give you probably 1 mark for that, half mark for that, and a half mark for the answers. D. Well, friction is mu times the normal force. I guess mu is going to be friction divided by the normal force. Hey, what did I find in part B? Friction. What did I find in part C? Normal force. Pretty cool. 124, I'm actually going to use 123.61. That's the nice thing about having a multi-line display. I can see a couple of values. 123.61 over, and I'm going to use 375.27. In fact, I'm going to use my answer button. 123.61 divided by answer button. 0.33, 0.32, 0.34, depending on what you round it off to, but I'm going to go 0.329. 1 mark. I would give you probably a half mark if I saw that, and then a half mark for the answer. Can you give yourself a loverly score out of, is this only out of 22? I should have made it worth more.